Now, my students, let us proceed with our today lesson, which is concerned about the so-called musical instruments. We have done with the types of musical instruments, and after the end of this video, I'll accompany you with a certain music where you will see the how different musical instruments can produce sound. Now, at this time, you are going to look these terms. They are very, very important terms, and in most cases, you'll be asked either to define or to calculate. These terms are fundamental notes, overtones, and harmonics. Without wasting time, let us begin with fundamental note. Fundamental note. I think you remember about the meaning of fundamental. Fundamental means primary, the initial, and it has the symbol F note, which is initial. Now, the fundamental frequency of a fundamental note of a musical instrument is the lowest possible. This is lowest possible frequency or pitch. The lowest possible pitch or frequency or pitch produced by musical instrument. Remember, musical instrument. I said we have strings as in a string instrument. That strings have different lengths, have different thickness. Therefore, why? So as they can produce different frequencies or large number of frequencies, large range of frequencies. Therefore, the lowest possible frequency which can be produced by those instruments is what we call fundamental note. For example, we take of the case of a flute where we have different holes. The lowest possible frequency produced from any of these holes is what we call the fundamental note. Therefore, fundamental note is the lowest possible frequency produced by a musical instrument. Now, for example, let's assume we have the following. We have, let me assume we have these small numbers: 2 hairs, we have 4 hairs, we have 6 hairs, we have 8 hairs. Among these, what is the fundamental frequency? Among these, the fundamental frequency is 2 Hz, but because in this series, the 2 Hz is the one which has lowest possible frequency. That is what we should note. The fundamental frequency, therefore, is characterized by low pitch. Therefore, fundamental frequency has high pitch, but also it is characterized by, look, for example, a string. A string produces a fundamental frequency, the lowest possible frequency, when it is plucked once. And now when it is plucked once, it appears of this shape. Do you look this shape of a string when it's plucked once? Remember, it is fixed on each end. Now when you pluck at the middle, it forms the mode of vibration like this one. Do you see what is here? The mode of vibration here has high amplitude. Therefore, the fundamental frequency has low frequency, but it has high amplitude. The big concept which you must know, and I think it is even came to the last year exam, it is saying the fundamental frequency alters. That means changes during a day. Alters. Why? Because fundamental frequency is affected by temperature. You know, we have a string. Due to temperature, a string can expand or can contract. Therefore, when it expands or contracts, that means it affects the fundamental frequency. Therefore, that's why you are saying fundamental frequency can alter during a day. Why? Because of air temperature. Now, due to the factor that fundamental frequency alters during a day, the musician, before using the instruments, they are advised to check or to adjust the position of the length of the string, if the string, before they have started using that instrument. Why? Because the fundamental frequency of the instrument can alter. I hope that is well understood as fundamental frequency concerned. The lowest possible frequency which the music instrument can make. We have another term which is called overtone. When you talk about overtone, this is another terminology. Overtones, we give them the symbol Fn dash, where n depends on the numbers, but dash is, we want to make it different from harmonics, because later on we're going to look harmonics. When we talk about overtone, we talk any. Here the word any. Overtone means any frequency which is greater than fundamental frequency. Any frequency greater than fundamental frequency, it is called overtones. Any frequency greater than fundamental frequency is called overtones. The first overtones is the frequency which is higher than fundamental frequency. Anyway, yes, it is like that. The first overtone is the lowest frequency but higher than fundamental frequency. For example, look here. Let us have the same. We have 2 Hz, we have 4 Hz, we have 6 Hz, we have 8 Hz. The lowest possible frequency is this one here. What is overtone? Overtone is any frequency greater than fundamental frequency. Therefore, these all are the overtones. But you cannot say the overtones are 4, 6, and 8. We'll be asking, what is the first overtone? The first overtone is the lowest frequency, is the lowest overtone, but highest, which is higher than fundamental. Therefore, among these, what is the lowest frequency? Is 4 Hz. Therefore, this one will be termed as the first overtone. This is 4 Hz. Second overtone is 6 Hz. The third overtone is 8 Hz, etc., etc. Therefore, overtone is any frequency greater than the fundamental frequency. The first overtone is the frequency which is greater than fundamental but lower than the rest of the frequencies. The big concept to note is the overtone for different instruments is different. If a flute has different overtones as a piano. Now I think you remember. If a flute and a piano are played at the same note, they are going to give us different overtones. They are going to give us different waveforms, because the waveforms are the ones which give us the overtones. Because waveforms tell us about a certain frequency, a certain overtones. Therefore, simply because the overtones are different, therefore overtone is played as a lull or a background, which is used to distinguish between two different instruments played at the same note. Lastly, harmonics. Harmonics, when you talk about harmonics, the key concept here, these are all frequencies, but are the frequencies which are multiple. Frequencies which are multiple. This is what you should note. The frequencies which are multiple of fundamental frequencies are called harmonics. frequencies which are multiple. Overtone, I said, is any frequency, but harmonic, they are not any. There must be multiple. I think you know multiple. That means should be 1 times, 2 times, 3 times, 4 times, etc. 1 times what? Fundamental frequency. 2 times what? Fundamental frequency. 3 times what? Fundamental. 4 times what? Fundamental. Therefore, harmonics are the frequencies which are multiple of the fundamental frequency. Look here. For example, we have this one here. 2 Hz, 4 Hz, 6 Hz, and 8 Hz. Do you see this one? This is the harmonics, because this is 2 times. This is the fundamental frequency, first of all. But is this the harmonics? Yes, because this is 2 times 1. This is harmonics? Yes, because it is formed by taking 2, which is fundamental, times 2. 2 is the multiple. This is formed by taking 2 times 3. This is formed by taking 2 times 8. Therefore, this all, they are harmonics. This is the first harmonic, this is the second harmonic, this is the third harmonic, and this is the fourth harmonic. Harmonics is nothing but the frequencies which are multiple of the fundamental frequency. And the first harmonic is the fundamental frequency is the first harmonic. But again, look here. Let us assume we have this one here. We have this series here where I have 2, I have 4, I have 5, I have 6, I have 7, I have 10, for example. And you have been asked to tell us what are the harmonics here. First of all, the first harmonics is the fundamental frequency. Therefore, my first harmonic is what? Is 2, because 2 is the lowest possible frequency among these. What is the second harmonic? What is the second harmonic? The second harmonic is the multiple of the fundamental. It can be 2 times, 3 times, 4 times. Therefore, we have 4 because it is 2 times 2. Therefore, we have is 4, which occurred by taking the fundamental frequency, which is 2, times multiple number, which is 2. Is 5 a fundamental harmonics? No, this is not harmonics, because this is not multiple of the fundamental frequency. I think you have now understood. Is 6 a harmonics? Yes. Therefore, my third harmonic is 6, because it is formed by taking 3 times 2. 2 is the fundamental frequency. 3 is the multiple number. Is 7 harmonics? No, because this is not a multiple of 2. This cannot be formed from 2. I think you know the table of 2. Is 10 harmonics? Yes, because it is formed by taking fundamental frequency 2 times a multiple number, which is 5. Therefore, the fourth harmonic is 10, which occurs by taking 2 times 5. I think you have now understood what does harmonics means. Now, can we comment that sometimes overtones, sometimes harmonics are not present in overtones. Sometimes harmonics are not present into overtones. What does it mean? We said overtones is the frequency greater than fundamental. Therefore, this is overtone, this is overtone, this is overtone, this is overtone, this is overtone. Why? Because all these are greater than 2. But are all these harmonics? No. Why? 5 is not harmonic because it is not multiple of the fundamental frequency. 7 is not harmonic because it is not formed from, it is not multiple of fundamental frequency. That's why we can comment that not all harmonics are overtones, and not all overtones are harmonics because of their definition. Overtone are any frequency higher than fundamental. Harmonics, that frequency must be multiple of the fundamental. I hope you have understood that part. Lastly, we are going to look on the concept of finding the number of harmonics. You'll be asked, what is this harmonics number? Now, if you want to know this frequency is of which kind of harmonic, is it first harmonic, is it second harmonic, is it third harmonic, is it fifth harmonics, and whatever. This is simple. For you to have nth harmonics, the number of harmonics, what you are required to use, you take the overtones over fundamental frequency. If you take overtones, you divide by fundamental frequency, you are going to know that frequency is of which harmonics. For example, we have 2, 4, 6, 8, and 10. You'll be asked, what is the harmonics of the 6 Hz? The harmonics is overtone divided by fundamental. Therefore, 6 Hz, you divide by fundamental, which is 2. Therefore, 6 is the said harmonic into these vibrations. I hope that is well understood, and that make up the end of today's presentation. Thank you very much. See you in the incoming lectures. Bye.